Hello everyone, thanks for coming. Today we'll introduce some extra topics in addition to our class, Introduction to Artificial Neural Network Models. The neural network models are widely used nowadays in computer science. Neural network, to put it simple, can be seen as a uniform function approximator using the artificial neural network structure. It is using the feed-forward structure to make predictions. So given any arbitrary function f of x, we want to approximate it by a neural network model f hat of x and theta. Theta is a parameter in the neural network. So we first pass x to the neurons in the first layer. The layers will use some linear combination and activation function to get the new value and pass to the next layer, and the next layer will handle the inputs and then pass to the prediction f hat. So this feed-forward structure is the core of the artificial neural network. The number of layers is called the depth, and the number of neurons in each layer is called the width. Depth and width are crucial parts of the neural network because they determine the representation ability of the neural network. So next I will introduce some typical applications of neural network models. We have the convolutional neural network for computer vision. So the convolutional neural network will take, let's say we're dealing with a picture, and it will take adjacent pixels in this figure to generate an output, which we also call a feature. So it can also be used to develop differential equation solver, because if we are taking a derivative, then we need to look at the neighborhood in a given point x. We are also applying the convolutional layers in graph neural networks because we need to look at the neighborhood of a vertex. So we need to attend to the local properties. The next area is the application of recurrent neural network, the earliest neural network model for machine memory. So suppose we are dealing with a time series data. We input x and we output y, but each yi it does not only depend on xi but also depends on the past trajectory from x1 to xi-1. How can we deal with that? So for the recurrent neural network model, it introduces a hidden variable. So first, given the random initialization, we combine the random initialization with x1 to get y1, and then we modify the initialization to h1, the current memory, and then given x2, we update the memory to h2. Combining x2 and h2, we get y2, and then we update h2 to h3 given the next input. So hi is the memory in the machine learning model. So based on these concepts, we developed the transformer model, which is the most advanced model that are widely used nowadays in the ChatGPT and other large language model. So let's say we're dealing with one sentence, we want to translate it into another language. So for translating each word, we not only need to look at this word, but we also need to look at the complete sentence to determine the exact meaning of this word. So that is the core of the transformer model. Finally, reinforcement learning is a little bit different from the convolutional neural network model or the transformer model because it is for decision-making tasks. Suppose we are to achieve certain objective, but to arrive at this objective, we need to take multiple steps and arrive at some intermediate states Si. So the reinforcement learning is for such decision-making tasks to determine the intermediate actions AI. So basically, we do this process again and again, and we gradually improve our prediction, improve the action we are taking. An application would be the AlphaGo for playing Go, as the AlphaGo can beat the top human athletes in playing Go. It is taking turns, and the Go is a very complicated game, so we need to take different multiple actions to play the chess. Also, if the action space is very complicated, then people are using the policy gradient method nowadays. Thanks for coming.